Hey, what's up everybody? My name is Moss, and in this video, I'm going to introduce you to GitLab CI. More specifically, I'll walk you through the creation of your first GitLab pipeline. In order to follow along, all you'll need is a GitLab account and a GitLab project to work with. If you find this video valuable, please consider throwing a like on the video and subscribing to the channel for more videos like this. If you haven't already, go ahead and grab a coffee and let's get started. So the first thing I want to do before creating our pipeline is provide a high-level overview of GitLab CI/CD and some key concepts. GitLab CI/CD is essentially an automation engine for your software development process. It includes a subset of GitLab features that allow you to perform DevOps practices like continuous integration and continuous delivery/deployment. It's comparable to a tool like Jenkins, which also serves as an automation engine that facilitates DevOps practices. With GitLab CI/CD, you can automatically build, test, and deploy your software project using GitLab pipelines. A GitLab pipeline is a version-controlled YAML file called .gitlab-ci.yaml that lives at the root directory of a GitLab project. If you're not familiar with the concept of a CI/CD pipeline, it's essentially an automated set of sequential steps to build, test, and deliver/deploy your code. GitLab pipelines are made up of two main components. The first component is a job. A job describes what needs to be done and could include commands to compile, test, or deploy code. The next component is a stage. Stages define the order in which jobs will be completed. A pipeline is basically a set of instructions for a program to execute. And the program that executes jobs in a GitLab pipeline is called a GitLab runner. GitLab Runner is a separate program from the GitLab application itself, and you can run GitLab Runner on your local machine, a VM, or even a Docker container. It is similar to the concept of a Jenkins agent. At pipeline runtime, GitLab assigns pipeline jobs to available GitLab runners. There's more to discuss about runners, but I'll cover that once we get into the pipeline creation. Now that we've covered GitLab CI/CD and its key concepts at a high level, let's start creating our first pipeline. Okay, so I'm currently inside of a GitLab project that I created. It's called GitLab-CI-introduction, and there isn't anything in the repository as of right now. There's just a README file in this GitLab project. And I'm going to create a GitLab pipeline for this project. So in order to create a pipeline for a GitLab project, we would navigate to the CI/CD section of the left-hand side menu, and we would either select pipelines or editor. First, I'm going to navigate to the pipelines page. So I'll click pipelines. And on this page, since we don't have a pipeline created yet, it shows us this list of curated CI/CD templates that are based off of tech stacks. So you can see here we have an Android template. There's also a template for Go projects, Gradle projects, Maven projects. If I keep scrolling, you can see there's a template for Python projects as well. For just about every tech stack that you can think of, there is a GitLab CI/CD template pipeline that you could start with. If we didn't want to use one of these templates, we could also just create a .gitlab-ci.yaml file at the root directory of our repository. But I think if you're not using one of these templates, the best way to create a new pipeline is to use the pipeline editor on this page. So from here, I'm going to select Create New CI/CD Pipeline, and this file is going to be created on the main branch. And it then takes me to this browser-based pipeline editor. And if I scroll down here, you can see we have this template pipeline that's just a very basic, bare bones template pipeline that we could use if we wanted to. It's not technology specific in any way. It's just kind of assumes the most basic steps of any CI/CD pipeline. Before we review this pipeline though, I'd like you to notice at the top of the page here, it says, this GitLab CI configuration is valid. And one of the benefits of using the browser-based pipeline editor is that as you're editing your pipeline, GitLab is evaluating it, and it will tell you whether or not your pipeline configuration is valid. And if you have any syntax errors, it will let you know at the top of the page here that the pipeline is not going to run. Now, this validation is also available as an extension in VS Code if you use VS Code and you'd like to edit your pipeline locally in your IDE. So you can install a Git, I believe it's called a GitLab workflow extension, and it includes this functionality where you can validate your CI configuration um, from the command palette. Another really useful feature of the browser-based pipeline editor is automatic syntax highlighting. So as you're writing your pipeline and you add certain keywords, so for instance, the artifacts keyword, what it should be doing is automatically suggesting matching keywords like artifacts keyword, and it will also provide like a short description of what that keyword does. The only problem you notice here that it's not automatically suggesting keywords. There's currently a bug that is preventing this feature from working, and there's an open issue in GitLab's project on GitLab that is supposed to address this particular bug. After some research on Google, I found a matching issue. You can see here it says pipeline editor autocomplete should trigger based on cursor position. This was created 2 months ago, and yeah, it's labeled as a bug. So you can see here what is expected. As the person types, it should be suggesting keywords. So it's unfortunate that this feature is not available at the time of recording, but I did want to mention that as a benefit of using the online uh, pipeline editor. Two other nice features of the pipeline editor are these two tabs at the top. We have a visualize tab and a lint tab. So if I navigate to the visualize tab, it will give me a graphical version of what this pipeline currently looks like. And then we also have the lint tab, which gives us a breakdown of our CI configuration, lets us know if our pipeline syntax is correct. So let's navigate back to the edit tab, and I'm going to delete these comments here. And let's quickly walk through how this pipeline is currently structured. So on line 2, we have the stages keyword statement. So this pipeline is pretty standard. It has a build stage, a test stage, and a deploy stage. Stages are executed in the order that they appear in this list below the stages keyword. So we see that the build stage is the first listed, and that's also represented in the visualize tab. You can see from left to right, the build stage is the first stage. And if I wanted to, I could switch the build and deploy stage. So if I made the deploy stage first, then we take a look at the visualize tab, you can see the deploy stage would be executed first, then the build stage, and then the test stage. Stages are typically defined somewhere near the top of the pipeline, as you can see in this example. Now, after the stages definition, we then have job definitions. So starting at line 7, we have the first job defined, and it's called the build job. As its name suggests, the build job is associated with the build stage, so it should be compiling code or building our application. And to associate a job with a particular stage, we would use the stage keyword under the job definition. So under the job name, we have the stage keyword, and then the value is the name of the stage. One thing to note is that a job doesn't have to be associated with a stage. It can execute as a standalone job. However, the one keyword that is required for a job definition is the script keyword. The script keyword allows us to specify commands that the GitLab runner assigned to this job should execute. Similar to the stages definition, these commands are executed in the order that they are listed here. And as you can see, it's basically invoking shell commands like echo. So anything that you could do at the command line, you could pass in to this script keyword. So if you needed to build a new Docker image or compile C code using make, or compiled Java code, you can invoke those tools and utilities from here. If I continue to scroll, we can see that there are two test jobs. There is a unit test job and a lint test job. And what you'll notice is that both of these jobs are associated with the test stage. So they're going to be executed inside of the test stage. And this is represented visually as well. So under the test stage, you can see both the unit test and the lint test jobs are listed under the test stage. And what this means is that by default, both of these jobs are going to execute in parallel. They're not going to wait on each other to finish in order to execute. They'll both start executing as soon as the test stage has begun. And then the final job in this template is the deploy job. There's nothing really special about this job. It's just associated with the deploy stage, and then it has these kind of fake these echo statements saying that it successfully deployed the application. So what I'm going to do is modify this template a little bit. The first thing that I want to do is remove these sleep statements. So the first one on line 24, sleep for 10 seconds, and the one under the unit test job, sleep 60 seconds. I'm going to remove those sleep statements. The next thing I want to do is modify the build job to produce a quote unquote executable binary file. So the output of the build job should be some sort of binary application that you can run and will be used by the test job and the deploy job. So under the script keyword in the build job, I'm going to add another command, and I'm first going to make a new directory. So make directory, and then we will call it the build directory. And after we create the build directory, I'm going to add another command, and we will echo my application binary file. And we'll write that to a new file within the build directory called executable binary file v1. Okay, so this is just a text file, but we'll pretend that it is a binary executable that is being produced from the build job. The next thing that I want to do is modify the unit test job to utilize and consume that executable binary file that was generated in the build job. So below the script keyword in the unit test job, I'm going to add a new command under the script keyword, and we are going to cat the binary executable file so that we can see what's written to it, which should be this string here. After the invocation to cat, I'm going to reference a predefined environment variable called CI underscore project underscore directory. And this is an environment variable that I did not create myself. It is provided by GitLab, and it's made available to a GitLab runner when it's executing a job. After specifying the project directory, we will then specify the build directory, and then finally the executable file. So executable binary file v1. So now that we're referencing that file in the unit test job, I want to run the pipeline so that we can see the output and review the output of the pipeline. So I'm going to scroll down here, and we're going to leave the commit message as the default commit message. And as soon as I select commit changes, the pipeline will start running. So I'm going to select commit changes. And once I select commit changes, it checks the status of the pipeline, and then it will show up here once the pipeline has started running, and we can open up the pipeline. Okay, so I'm going to select view pipeline in a new tab. And from here, we can see the graphical view of the pipeline and the status of each of the jobs within the pipeline. And what you'll notice is that the build job succeeds, the lint job succeeds, but the unit test job, the job that was referencing the quote-unquote binary file that we created from the build job, failed. So let's take a look at the console output of the unit test job to see what failed within the job. So I'm going to select it, and it takes us to this console output of the job. And let's walk through this output. So it first starts out by allocating and running a specific GitLab runner. Once it allocates the runner and it creates a new environment for the job to be executed in, it clones down the repository to the local workspace. And then you can see starting at line 21, the commands that were specified under the script keyword begin executing. So first we see the echo statement for running unit tests, then we see the echo statement for code coverage, and then on line 25 we see the cat statement where we try to cat our our executable file, and it says that there is no such file or directory, and this appears to be why the job failed. Now the reason that it couldn't find the file that we created from the build job is because each job runs in a fresh environment. And jobs are not being executed in a shared workspace the same way that a Jenkins pipeline is. So a Jenkins stage has access to the artifacts that may have been generated by a previous stage, such as the build stage. But in the case of GitLab, each of these jobs are being executed in a separate workspace, and they don't automatically share the artifacts that are produced from one stage to another or one job to another. And real quickly, I'll show you the documentation for this, the GitLab documentation. It says one important difference is that jobs run independently of each other and have a fresh environment in each job. So if we have any artifacts that need to be passed between jobs, that is controlled using the artifacts keyword and the dependencies keyword. So in our case, if we want that binary file to be available to the unit test job, we need to utilize the artifacts keyword in our pipeline. So let's navigate back to the pipeline editor. And then I'm going to scroll down to the build job. And I'm going to add a new keyword under the build job definition. And this is going to be the artifacts keyword. The artifacts keyword allows us to specify files that should be shared with downstream jobs in the pipeline. And this keyword also allows us to download those specified artifacts to our local machine after the pipeline has completed. So for instance, if the job generated a test report, we may want to download that and review it after the pipeline is completed. And to do so, we can utilize the artifacts keyword. In our case, we want to specify the path of a file. And to do that, we would just specify paths under the artifacts keyword. And then under the paths keyword, we can specify one or more file paths that should be artifacts produced from this job. So I'm going to specify the build directory and the executable binary file. Now, after completing the script section, the GitLab runner that's executing this build job will upload this file to GitLab. And then any downstream jobs like the unit test job will first download any available artifacts from GitLab before executing their commands in the script keyword. So let's go ahead and commit our changes and see if this fixes our pipeline. So I'm going to select View Pipeline. And I'm going to open up the unit test job. Now in the unit test job, we can see that the job succeeded. And starting at line 16, the unit test job downloaded artifacts, and it says downloading artifacts for build job. And then it specifies the token of the artifact. And we know that the file was downloaded successfully because the cat command works, and we can see what's inside of the of our executable file on line 26. A couple of other things that are worth noting from this console output page is on the right-hand side, it shows the duration of this job. It took 12 seconds. And we also get timestamps, or not timestamps, but we get duration within the job as well. So here we can see it took 1 second to download artifacts. And for each step within the job, we get this duration. It also tells us how long ago the job finished. And then we have this timeout period, which is currently set to 1 hour. And that means that if this job is still running at 1 hour, it will be timed out automatically and it will no longer run. And this timeout period is very useful if you're using um, GitLab runners that are hosted by GitLab, because you're paying for the time that you're using those GitLab runners. And then we can also see which runner executed this job. So let's navigate back to our editor. Actually, before navigating back to the editor, let's navigate to the Pipelines tab. And from here, if we take a look at our latest pipeline, and I navigate to the right here, this is where artifacts can be downloaded. So if I select uh, this button here, I can then download the artifacts that were produced from the build job, which should just be that single file, and download them to my local machine. Okay, so now let's go back to the pipeline editor. With the artifacts keyword, we now know how to pass the output from one job to a downstream job. But let's say that we needed the JDK installed so that we could compile our Java project. How would we go about doing that within a pipeline? Well, in Jenkins, we have the tools section, which allows us to install tools like the JDK onto the host that is running the Jenkins pipeline. So the Jenkins agents will be running on a particular host. And if a pipeline has a dependency like the JDK will be installed on that host. And then on future runs of the pipeline on that host, it won't need to reinstall the JDK. GitLab doesn't have an equivalent to the tools section in Jenkins. Instead, GitLab suggests using Docker images that contain all of the dependencies you would need in order to, build, test, and deploy your code. Now, how would we utilize a Docker image inside of a GitLab pipeline? Well, we can actually specify a target Docker image using the image keyword. The value of the image keyword should be the name of the target Docker image that you would like the GitLab runners to use. So for instance, if Python was a dependency, we needed Python installed in the runtime environment of this pipeline, we could specify the Python Docker image. And if we needed to, we could also specify a particular tag along with our image, like the latest tag or an earlier tag. Now, what will happen after specifying this image when we run the pipeline and a job is executed by a GitLab runner? The GitLab runner will pull the Docker image that we specify here, run a container from that image, and then it will execute all of the script statements that we specify within the job definition within that container. So if that Docker image has Python installed on it, then we will be able to invoke Python from a command under the script keyword. And that's exactly what I'm going to do. So I'm going to add a space here and then scroll down to the deploy job. And let's add a command under the script keyword in the deploy job. And we're going to invoke Python 3 and then the version command. So this should print out the currently installed version of Python. And let's go ahead and commit those changes and see what happens when the pipeline runs. Okay, and I'm going to select View Pipeline. And I invoked Python in the deploy job, so I'm going to select the deploy job here. And the deploy job should begin pretty quickly. Okay, and the deploy job has begun. And starting at line 4, you can see that it says using Docker executor with image Python, and then it is now pulling the Docker image for Python. Okay, and it looks like the job has completed. So if I scroll down after it's cloned the repository, it's downloaded artifacts. On line 21, it says deploying application. And then on line 23, we see the invocation to Python 3. And on line 24, you can see the version of Python is printed out to the console. So if we have any dependencies like Python or the JDK that need to be installed in the environment that the job is being executed in, then we can utilize the image keyword and pull a specific Docker image. And if we have a custom Docker image, we can also use a custom Docker image as well from a registry, a container registry, either within GitLab or outside of GitLab. Okay, so let's navigate back to our pipeline editor. Now, it might be the case that you need to authenticate with an external service during pipeline execution, or maybe there is some sort of environment variable that needs to be accessible to one of the jobs, and you might need to define those environment variables. So how would you do that for GitLab pipeline? In order to define variables that can be used by GitLab runners when executing jobs, we can use the variables keyword. Under the variables keyword, we can specify key value pairs of environment variables. So for instance, let's say I needed to authenticate with a particular service. So I needed a username environment variable. What I can do here is specify the key of the environment variable, and we'll call it username. And then I'll set the value of the environment variable to tech with Moss. Now, if there's a password or a token associated with this username environment variable, should I define that password under the variables keyword in the pipeline? The answer is probably not, because this pipeline gets version controlled with the repository. And so that password would be also version controlled in plain text, and that's not ideal. So if we have any environment variables that might be sensitive, like tokens or passwords, we can actually create those variables from the settings tab. So if I scroll down to settings, and then I'll open the CI/CD settings in a new tab. And from here, I'll scroll down to the variables section. And under the variables section, we can create new environment variables that would be available to our pipeline. So you can see here it says variables store information like passwords and secret keys that you can use in job scripts. And they can either be protected or they can be masked, or they can be both protected and masked. Protected means that they're only exposed to protected branches or tags, and then masked means that they're hidden in job logs. So I'm going to select add variable, and the key will be called password, and then the value will set to my password. And it's of type variable, and we'll leave it with the default environment scope. We'll also leave it as a protected variable, and then we're going to select mask variable. And when I select add variable, you'll notice that the key shows up here, but under the value, it is not shown, so it's masked. But if I have the right permissions in this GitLab project, I can reveal the values, and we can see that the value is my password. So let's reference this password environment variable in our pipeline. So if I navigate back to the pipeline editor, I'm going to scroll down to the deploy job, and under the command where we invoke Python 3, I'll add a new command. And what we're going to do is simply echo the username and password environment variables. So I'll say echo using credential, and then username, password. And let's go ahead and commit those changes and take a look at our pipeline job. Okay, and it looks like the deploy job has begun. So I'm going to open that job up. So the job has succeeded, and if I look at line 25, I can see the echo statement using credential, username, and password. And then on line 26, we can see the output of that command. And we see that tech with Moss is printed out to the console, but as we specified in the CI/CD settings, the password value is masked in the job log output. So it looks like our pipeline is running as expected, and I don't want to make any additional changes to the pipeline, but there are a couple of other things that I'd like to show you before closing out. The first thing that I'd like to show you are the settings for GitLab Runner. So if I navigate down to the settings tab and we navigate back to the CI/CD page, there is a section for GitLab runners, and I'm going to go ahead and expand this section. And it says runners are processes that pick up and execute CI/CD jobs for GitLab. And if I scroll down here, we have specific runners and shared runners. And what I've been using in this tutorial are shared runners. And these are GitLab runners that are hosted by GitLab. Using shared GitLab runners is free, but it's limited to 400 CI minutes per month per group for private projects. Now, if I wanted to use my own compute resources instead of shared runners, so I wasn't limited by this quota, I could download the GitLab Runner program and I could run GitLab Runner on my local machine, a VM, or a Docker container on compute resources that I own. And then I would register that GitLab Runner with this particular GitLab project. And then when the pipeline is ran, GitLab would utilize the runners that I specify on the compute resources that I own and assign jobs to those particular GitLab runners. And under the shared runners section, we can see a list of available shared runners as well. The other thing that I wanted to quickly review is caching in a GitLab pipeline. So I'm going to navigate to the GitLab documentation on caching. And by the way, I'll include links to this documentation that I've been referencing in the video description. So in addition to artifacts and related to the artifacts keyword, you have the cache keyword, and this allows you to cache files that a GitLab job downloaded. So for instance, if your pipeline was running on a Python Docker image, but your project needed some set of Python packages like NumPy or scikit that weren't included in the Python installation, then you would need to download and install those dependencies at pipeline runtime. But you wouldn't want to have to download those dependencies every time the pipeline ran. So we can cache those kinds of dependencies using the cache keyword in our pipeline. And if I navigate to the keyword reference documentation for cache and scroll down, they have an example of where we're caching a particular file path. So under the cache keyword, we specify a key for the cache, and then we specify the paths, which might be a set of binaries or this config file. So going back to the caching documentation, with cache, subsequent pipelines can use the cache, and subsequent jobs in the same pipeline can also use the cache if the dependencies are identical. There are so many features that I haven't mentioned in this video that are available to you with GitLab CI/CD and GitLab pipelines, but I only wanted to cover a subset of features that I thought could get you up and running with your first pipeline and that you could apply to your own project initially. This video is just your first step into GitLab CI/CD and GitLab pipelines. As I said before, I'll include links to the key documentation that I referenced in the video, as well as documentation that I think is important to review if you want to continue expanding your knowledge around GitLab CI/CD and GitLab pipelines. But I hope you enjoyed this video and you found it valuable. If you did, please consider throwing a like on the video and subscribing to the channel for more videos like this. Thanks for watching.